matter.
Okay, we're going live.
All right.
All right, let's call that meeting to order. Thank you everybody for joining us for our virtual Macomb meeting. Here on the rare case where we have the Cranbrook meeting, the Macomb meeting in the same week as Astronomy at the Beach, which happens every couple of years. So, we just had our officer reports presented 4 days ago, so we'll keep that short. We are currently looking for members for the nomination committee. We are, of course, looking for new officers for next year since several officers are term limited out and need to be elected at the November meeting. We currently are in the process of putting together the calendar, thanks to Dale Teamy and Bill Beers, our calendar committee for this year. So they've got a lot of shots in the can already. We're having to go with a brand new calendar company since the old one that we have used for years now, Calyptic out of Canada, is unfortunately out of business. So it's going to be a little bit different this year, but we're expecting to get a lovely calendar into everybody's hands by the end of the year. We also, of course, have Astronomy at the Beach happening tomorrow and Saturday, usual 6 to midnight at Island Lake State Recreational Area. Bob, would you be able to cover that just in the scope of your report since I don't see Adrian
Sure.
on the line yet?
I'm
All right.
getting a link for it right now.
Excellent. And we do have the Big Dub will be there thanks to a new volunteer trained by Jeff McLeod, Greg Nizen. So the Big Dub will be making an appearance. In fact, I got a phone call at 7:45 this morning from somebody who was very panicked, thinking that the Big Dub had been stolen. So I'm hoping somebody on this call will be able to confirm that everything is okay. I see Riyadh nodding his head. Yeah, that was a way to wake up this morning. Otherwise, yeah, things are winding down. If you have any candidates for the Distinguished Service Awards, that's the Searles Award, the Kalinowski Award, the McCullough Award, or the Bob Watt Hands-On Award, let the board know because we are interested in recognizing people. So I'll turn things over to you then, Riyadh.
Thank you, Diane. Hello, everyone. So yeah, the short version of my report is that we had our picnic on August 27th, and it was one of the best picnics we've had in quite a while, to be honest with you. We started out around 3 o'clock. We cleaned the 22-inch Bob optics, which needed cleaning for quite a while now. And we also opened the observatory, so we were able to do some solar observing. And then we started the picnic around 5 o'clock. Mark Kadir was doing all of the cooking for us, and he did a wonderful job. And we had a lot of people that showed up actually for that day and stayed till I closed the observatory about 2:30 a.m. So we stayed pretty late. We were able to observe a number of objects, including Saturn, Jupiter, and later on Mars. So the next open house is scheduled for Saturday, September 24th. And of course, tomorrow and the next day, we have the Astronomy at the Beach. So that's all I have right now. Back to you, Diane. Thank you.
Neptune. You saw Neptune, right?
Neptune as well. Yes. Thank you.
Thank you. All right. Over to you, Bob, for the first vice president's report.
All right. We're going to be having Gary Ross is going to be giving a talk on October 3rd. And I talked with Dale Parton. He's going to be giving a talk probably on the Europa Clipper in mid-October. So October is looking good. As Diane mentioned, Astronomy at the Beach is happening this weekend. I put a link in chat for that. Nicole Zellner is the keynote speaker, and she's giving 2 talks. The first talk on Friday at 8 p.m. is To the Moon, Michigan's Contribution to the Apollo Program and Beyond. And on Saturday, she's giving a talk at 7:45, Life in the Universe. We've got solar observing going on from 4 to 6 p.m., both Saturday and Sunday. Sandra Masika is doing her meteorite and tektites talk every hour, pretty much on the hour all weekend, so she's there. Tim Campbell and Liam Finn are giving a talk on the James Webb Space Telescope each evening. John McGill was going to be giving a presentation, but he caught COVID, so he's not going to be able to, and he moved his presentation to online via Zoom. I will not be able to make the event either, so I'm giving 2 presentations each night, also via the Zoom, and the links for those are all at the schedule page. So, Astronomy at the Beach is looking busy. A lot of stuff going on. We're looking to have a lot of people out there, and I hope everybody practices safe distancing and COVID prevention stuff, because even though the CDC is saying that, hey, it's over, it's not over. But anyway, back to you, Diane.
All right, thank you, Bob. Really excited to have Nicole Zellner, since we actually recruited her some years back for previous engagement with AATB, and she did a marvelous job. So excellent.
I actually recruited her to speak at a science fiction convention once, and she was very, very good.
Fantastic. Okay. Over to you then, Mark, at the secretary's desk.
Hi, good evening, everyone. I have nothing to report. The minutes of the last month's meeting are in the WASP, and I will be at AATB operating the Dob with a few other individuals. So hope we get a big crowd out there. That's all I have to report.
Fabulous. Mark is the quiet guy who's been doing a whole ton of the work from the picnic to the telescopes this year. So kudos to Mark. All right. Don't see Adrian. Isn't he usually doing softball or bowling or something like that? Anyway, treasury report is in the WASP. We are solvent, as treasurer of old used to say, but actually we've got about $30,000 in the bank. So we are looking for ways to responsibly spend that to better the club. Riyadh has given us a shopping list of quite a few nice things that we've acquired this year. Details in the various officer minutes to make Stargate better, but we are still pursuing the possibility of a third building, a warming room, and a roll-off roof observatory up there at Wolcott Mill. So, okay. Let's see. Oh yes, Kevin McLaughlin at Outreach. He's traveling for work this week. Big outreach thing on the agenda, of course, is again astronomy at the beach. So if you do decide to volunteer in any capacity, do let Kevin know by emailing him at outreach@warrenastro.org so that you can be included in our official reports recognizing those who served. And with that, over to you, Dale Teamy at Publications.
Well, the WASP is online for September, and the October issue is well underway. The calendar is getting very close to sending off to the printers as we speak.
Fabulous. All right, thanks again for getting that facilitated, especially this early in the year. As far as special reports go, if you want to do solar observing, get there early to Astronomy at the Beach. There should be solar telescopes marked by yellow balloons out on the field, and you can get a look at what the sun is up to, assuming we actually have a sky. Bob, what's the weather report looking like for the next 2 days?
Oh heavens!
So I was out in
One
Northfield
thing I want to see
today,
is
it
nice
wasn't
and
great.
clear.
Anyway, well, Bob pulls that
Anyway,
up.
yeah.
Double Star Group will also be convening the next time we meet at Stargate, which is, of course, the 4th Saturday of the month. So Riyadh and the gang will be out there ready to look at double stars. And y'all saw some real nice ones at the picnic, right, Riyadh?
Yeah, absolutely. And we saw a lot of them actually. So we were going from one to the other.
Fabulous. Sorry I wasn't able to be there. Next time. Okay. History groups, as always, is chronicled in the WASP since the history group chairman is our publications editor. The Astronomical League is in that period between registration drives. So if you would like to become a member, you're going to have to wait until the beginning of the year. And for those of you who are members, the reflector should be hitting your mailbox soon. I haven't got my copy yet, but Adrian said he got his. Finally, discussion group. We had I guess a pilot return to the old ways discussion group hosted by Laura Wade a couple of months ago, end of July, in her backyard. 6 people showed up for Laura's hospitality and enjoyed some really good food, so I heard. I was at Stellafane of Vermont that weekend. We haven't had a host yet. I know everybody ought to be getting their bivalent booster. But I did talk to John Blum, our traditional host of the November pre-Thanksgiving discussion group. He said he and Rosie are very much in the camp of this is not over and they would like to decline to host for the time being. Can't blame them. It's hit their family pretty hard. It's hit many of the board members' families pretty hard too. So, we may be able to get in another open air discussion group in somebody's backyard before things get cold, but if not, we may have to defer that until next year. So if you want to host, please contact us and let us know what your restrictions are. We will happily meet your restrictions. And with that, have we got some observing reports? Has anybody really done any observing in the last 3 nights?
No.
No.
So the weather, AccuWeather is telling me that 29% cloud cover on Friday, hot night, 11% cloud cover. And it's saying that Saturday there's a 6% chance of rain and it looks like it's partly cloudy. So not horrible. It's not saying mostly cloudy and showers anyway. So
Yeah, we've had downright thunderstorms, so
yeah,
that is definitely a not horrible report. How hot is hot for Friday night?
83 degrees,
Okay, that's
86 degrees
gross.
on Saturday.
That's gross. Riyadh, your hands up.
Yeah, just real quick. I forgot to mention one of the reasons why we observed so many double stars over the picnic is because we used the 6-inch aperture on the 8-inch refractor.
Oh,
which,
nice.
made the double stars extremely tight in grouping. And we were able to resolve some really good doubles, and there was hardly any color aberration to speak of at that point. So that worked very well, and I'm looking forward to using it again in the future.
Fabulous. All right. Well, if we have no observing reports out
The
there
only-
in the field,
I
Go
have
ahead,
one
Ken.
small one that happened. I'm
excellent.
a sports official for softball, and the other night we were at Novi, and the moon was rising last night actually, and as it was rising, it was very red in color. And somebody says to me, "Why is that so red right now?" And I explained to him, about the rainbow and the reason the sky is blue and everything like that. And I had about a dozen people there that were just sitting there explaining the fact that the when the moon and the sun are at the horizon, they're going through 1,000 miles of atmosphere as opposed to 50 right above us, and that the only light that's left is the red. And somebody says, "Well, isn't that what happens to the moon during a lunar eclipse?" And so we went through a little discussion. I was actually talking to them about 15 minutes, and I had about, I'd say 20 to 30 eventually that were sitting there. It was almost like a presentation. And it was kind of interesting to see the reaction of non-astronomers, as it were, and so that was an observing report that just lent itself to teaching, a little bit about astronomy, and I got a kind of kick out of that. So
Excellent. I think you
Yeah.
might have had some go ahead, Dale.
Oh, when you guys get done with this, do you want me to run that audio that Gary wanted us to play?
Yes, indeed. I think we have
Okay.
plenty of time for that now. I just wanted to chime in that I believe that the redness may well be exacerbated by the wildfire smoke coming in from the West Coast. As some of you
with no
know,
sound,
there's
no doubt.
fires from California all the way up through Washington, with ash falling on the city of Everett, Washington. And the west coast of Michigan was reporting ruby red sunsets about 2 days ago.
Yep.
Yeah.
There you go. More atmosphere and more nut stuff's going on out there, right?
Indeed.
Yeah.
All right,
Very
Dale.
cool.
Let's tell us a bit about this audio rather that Gary Ross wants to share.
Gary likes to listen to a CBC program on the radio called As It Happens. And every so often, topics in astronomy come up, and he likes to share those with us. This time around, it was a issue of, well, not an issue, but someone got the idea to take the images, data from the James Webb Telescope and render them as musical sounds, so the blind can enjoy what the JWST is showing us. So we shall go ahead and play that.
All right. Kick back, get your favorite beverage, and let's enjoy.
That's about 7 minutes long.
Sounds good to me.
You're hearing the sound of the Southern Ring Nebula as captured from across the universe by the James Webb Telescope. That's not actually literally the sound of space. It's a sonification and interpretation of images using sound and musical elements. The idea is to communicate all the majesty captured in the groundbreaking images supplied by the telescope in a way that they could be understood by people who are blind or visually impaired. University of Toronto physics professor and sonification expert Matt Russo headed up the project for NASA. We reached him in Toronto.
Matt, the goal here, as I understand it, was to translate these images into sound for people who can't see them. You have a visually impaired colleague on your team. What are you hearing from her and others who can't see these images?
Yeah, so that was actually some of the most heartwarming feedback we got, which is that Christine Malik, who's on our team and who's blind, she said that listening to these images gave her the feeling she thinks that sighted people have when they look at the night sky, and there couldn't be a better compliment than that.
It's pretty amazing. I don't even know how you begin to do it. How do you capture that magic?
Well, in this case, this is one of the more artistic sonifications. Other sonifications can be more direct, as in we can convert frequencies of light to frequencies of sound. But in this case, it's a little more artistic, but we're still using computer programming. We're still letting the information in the image control aspects of the sound.
How long did it take?
This took a few weeks, and we had a few different people on the team. So there were other scientists and writers from the James Webb Space Telescope, and also a blind consultant who's also a musician and an astronomy enthusiast. We've actually done a lot of these for NASA, and they get such an amazing reaction from the blind community, but also from people who are sighted. And so we think we're going to make it a more regular thing.
Could you guide us through the audio elements you use to interpret the James Webb images? These are the images that people are now coming to know as the cosmic cliffs. And before we hear it, can you give us a mental picture of the whole image, a quick snapshot?
Okay, so James Webb's image of the cosmic cliff shows the edge of a thick red star-forming nebula, so reddish clouds in the bottom half, and more diffuse bluish nebula in the top half. And the shape of the red nebula kind of looks like the edge of a mountain range, which is why it's called the cosmic cliff.
We're going to play the whole piece in just a minute, but can you take me through the layers represented in the images so we can put them all together? So there's a first layer of sound in your composition. What we're going to hear will represent the lower part of the image. So what should their ears be listening for?
So the bottom half of the image shows the thick red nebula with what look like mountain peaks. And as you listen, you can hear the rising and falling pitch, which traces the contour of that edge.
That's just layer one, though. Tell me about the second layer.
The second layer represents the top half of the image, and that's a more diffuse bluish nebula. It kind of looks like a nighttime sky, actually. And for that, we used a different algorithm that ended up giving us more of a windy sound.
Here's what that sounds like. Beautiful. But the final layer, I think, just blows my mind the most, and that's translating into sound, the stars. What should we be listening for as we listen to the sonification of those stars?
So this image contains thousands and thousands of stars, and we converted every point into a note. So the brighter stars are heard as louder notes, and the brightest stars, which have these diffraction spikes on them, which make them appear like the typical star pattern, those have an extra crash symbol to let you know those are the brightest of the bunch.
Here's what that sounds like. When we put all of those together, I'm going to play those as we continue to chat, Matt. What do you hope people are seeing in their mind's eye as they hear it?
I hope you're able to hear just the richness and complexity of the image. There's a lot of information, there's a lot of texture, but there's also these smooth, flowing lines in it. And I hope you can experience that through sound.
Matt Russo, thanks so much for this.
Thanks for having me.
Let's play that full sonification now of the cosmic cliffs.
Sonification of the James Webb Telescope's image of the cosmic cliffs, created for NASA by U of T physics professor Matt Russo. We reached him in Toronto.
And there you have it.
Interesting.
Yeah, I posted in chat when I was at Alcon 2012. We were at Yerkes. They did a sonification demo at a nearby high school auditorium, and that was pretty. It was very similar to this. So we're ready to have Haley.
Yes, absolutely.
All righty.
Take it away, Bob.
All right, yeah. So tonight's format is going to be like our Cranbrook, because I screwed up the scheduling. We're doing both a short and a long presentation. Haley, can you pronounce your last name? I should have asked you this. It is Belts?
Yeah, just like
Okay. Just wanted to make sure. Didn't make a fool of myself. So, all right. What happens when you take let me put this over here so I can look at the screen now I'm doing this. What happens when you take a Jupiter-sized planet and put it so close to its host star that it orbits every couple of days? These planets, known as hot Jupiters, represent exciting laboratories for physical regimes not seen in our solar system. In this talk, Haley describes how we find these planets, what their atmospheres look like, and open questions about their physical properties. Haley Belt is a second-year graduate student working with Dr. Emily Roscher. Is that how you pronounce that?
Oh, sure.
Rocher, yeah. She graduated summa cum laude with honors in physics and mathematics from Kalamazoo College. Previously, she has done work on ranking analysis in clustering methods of the U.S. Patent Network. Her undergrad astronomy work involved high redshift quasar absorption line spectroscopy, for which she received the 2018 Chambliss Astronomy Achievement Award at the 231st meeting of the American Astronomical Society. Her current work combines high-resolution spectroscopy and 3D general circulation models to constrained wind speeds and rotation rates of hot Jupiters. Take it away, Haley.
Great. Thank you for that introduction, and thank you for inviting me to give a talk. Yeah, so as he said, my name's Haley Belts. I need to update my U of M page because I'm now a 5th year grad student at the University of Michigan. And today I'm going to tell you about this really cool class of exoplanets that I study, known as hot and ultra hot Jupiters, and tell you about how we discover them and what we can learn from them. So what I'm showing you here is a range of all the exoplanets that have been discovered by date. So we are about a little over 5,000 exoplanets, meaning any planet that's orbiting a star that's not our sun. And on the x-axis, I'm showing you the period, so how long it takes for the planet to orbit its host star, versus the y-axis showing its mass in Jupiter masses. And then each of these points correspond to a different exoplanet. The color corresponds to the method that they were discovered. And I'll go over the most common methods discovered or used for hot Jupiters and ultra hot Jupiters, which I've kind of circled here in this regime. So they have really short orbital periods of on order of a couple of days, meaning that they're very close to their host star. And they're around a Jupiter mass-ish or so, meaning that there's nothing like that in our solar system. So they're really cool planets to study. And so most of these planets were first discovered through the transit method, which involves looking at a star and measuring its brightness throughout time. If you're lucky, the planet is going to come between us and the host star, and when that happens, the overall brightness will decrease, which is shown in this GIF on the left. So as the planet is between us and the host star, the brightness goes down, and it'll do that at regular periods every time it orbits. And so from a transit method, we can learn about the radius of the planet, because the bigger the planet, the more the light is blocked. Another method of discovering these planets or validating a transit is known as the radial velocity method. So there's a lot of stuff going on in this GIF, so I'm going to explain each little bit first. So this plot on the left is just showing a top-down view of a host star and a planet orbiting it. So the planet's orbiting the host star, and the host star is kind of also moving a bit, because as the star pulls on the planet is also going to pull on the star. And this view at the bottom is showing kind of from our point of view what the planet and the star look like. And so we can actually measure this movement of the star, known as the wobble, by looking at its spectrum, the light that it emits. So that is shown in these sort of rainbow lines, and the dashed lines show where the absorption features are when the star is just by itself normally. But as the planet pulls on the star towards and away from us, these lines are going to be red shifted and blue shifted according to how massive the planet is. And so the radial velocity method can tell us about how massive a planet is. And since hot Jupiters are both very close to their host star and very massive, we have an overabundance of them as far as the number we've detected, because they're the easiest types of exoplanets to detect. But importantly, what I study is sort of modeling their atmosphere and wondering what that looks like. And so I use 3D models to describe their atmospheres and numerically figure out what we think their temperatures and winds look like. So on the right, I'm showing you the output of one of our models for a hot Jupiter, and the color corresponds to the temperature. And these little arrows, the black arrows, are showing you the direction of the wind fields. This gray star is showing you the closest point on the planet to the host star. So that's called the substellar point. And this is important because since these planets are so close to their host star, they actually become tidally locked into synchronous orbits, meaning that there's a permanent day side that's constantly being irradiated, as well as a permanent night side that doesn't ever get to see the host star, much like we only see one side of our moon. And then these blue and red lines are, from the observer's perspective, measuring wind speeds that are both blue shifting and red shifting away and towards us. And so we keep track of these because when you want to make predictions of what the light from this planet will look like, that light is going to be shifted towards and away from us. And so if I start the GIF, we can see that the planet rotates, and right now we've got the day side in view, but as the planet rotates, the night side comes into view, which is much colder because it's not being heated by the host star. But a lot of the heat from the day side ends up getting blown to the night side, warming it. Despite this, there's still often temperature differences of over 1,000 Kelvin between the day side and the night side, making these planets really important to model in 3D in order to get all of these weird temperature effects. So another important feature of these planets is known as the equatorial jet. And that's what I'm showing on the left here. So the y-axis is showing us the pressure. So the top of the plot is corresponding to the top of the atmosphere, the top of our model. And then as you go deeper down the y-axis, you're going deeper into the planet. We only model about the top % or 2 of the planet because we can't observe anything deeper than that, and the physics going on down deeper in the atmosphere are different than the physics going on the top of the atmosphere. And then on the x-axis, I'm showing you the latitude with the 0 corresponding to the equator. And so you'll see this big pink shape in the center, which is color-coded by the strength of the winds. So the equatorial jet reaches speeds of many kilometers a second, and it goes down very deep into the atmosphere. And this equatorial jet has effects on the temperature structure of the planet. And so on the bottom right, I'm showing you a sort of temperature map at one pressure level of the planet. So longitude now on the x degree axis and latitude on the y. And so at 0, 0, that's the substellar point, the point on the planet closest to the host star. And if there weren't any winds on the planet at all, you'd expect that to be the hottest point on the planet because it's the closest to the star. But this equatorial jet is so strong, these winds actually push the hottest point on the planet slightly eastward, or I've indicated with this pink little cross. And so this is known as the hotspot offset, and is actually something that we can measure and compare our models to see if we're doing a good job of capturing these physics. So now that I've told you a little bit about their atmospheres, I want to go into the type of observations that we use to study these planets, because unlike for other parts of astronomy, it's really hard to just take a picture of an exoplanet like one could for a galaxy. The planet and the host star are so close to each other in the night sky, it can be hard to distinguish them. But we have our methods because we'll figure out how to study them. And the first method is known as transmission spectroscopy. So in this GIF, the black circle corresponds to the planet, and the color and changing in the background is the host star. And the radius that is circle that's going bigger or smaller is showing you how big the planet's radius is in various wavelengths. So when the planet is in front of the host star, some of the light from the star is going to be filtered through the atmosphere. But depending on the wavelength of light, different amounts of atmosphere will absorb the light. And so the radius will actually appear different at different wavelengths. So at the purple wavelength, the planet looks very small, meaning that only a little bit of light, or light is going through only a little bit of the atmosphere, while at the green wavelength, the planet looks very large, meaning that we get to see more of the atmosphere. And what determines sort of how much of the atmosphere we're seeing is the atmospheric composition. What species are there and where do they have their absorption lines? And so from this method, we can detect various ions in the atmosphere, we can detect different molecules in the atmosphere, and we can even also make estimates of the wind speeds of these in this upper atmosphere area, which can be really helpful to compare back to our models. The next method of looking at exoplanets is this concept of a phase curve. And so with this, we're measuring the total amount of light emitted from both the planet and the star throughout the entire orbit. And so this method isn't feasible for all types of exoplanets. Luckily for hot and ultra hot Jupiters, it only takes a couple of days for the planet to orbit completely. But if you have a planet that's further out, you're not going to get telescope time to look at a planet for 500 days straight. But since these orbital periods are so short, we can use these phase curves to learn more about the planet's atmosphere. Because as different points of the atmosphere come into view, either the hot day side or the cooler night side, that's going to change the total amount of brightness that we measure. And so we see these two dips in the phase curve that correspond to when the planet comes in front of the star and blocks some of the light, and then a second smaller dip when the planet goes behind the host star. And so from that, we can figure out, okay, this is how bright the host star is. This extra bit must be the planet. And this gives us sort of a time series information about how bright the planet is at different points in the orbit. And what these phase curves look like in papers is something like this on the left. And so there are two sort of important features that you can measure from phase curves. The first being the amplitude, which is just the difference between the brightest point of the phase curve and the least bright. And what that tells us is information about how much hotter is the day side than the night side. So it gives us the day-night temperature contrast. Additionally, the other piece of information we can get from phase curves is information about that hotspot offset. So we'll know when the brightest point of the planet is facing us, and we can, of course, figure out where that corresponds to on the planet itself. And so on this plot here, there's 3 different offsets that are shown at different levels of offset, which will move the brightest point of the phase curve slightly later in phase. And so that equatorial jet, we can get information about how strong it is and how much it's moving that hot spot by figuring out where the phase curve will peak in its brightness. And then finally, my favorite method for observing exoplanets is known as emission spectroscopy. And so here we're looking at the light directly emitted from the planet. And so this light is going to be highly influenced by the temperature and the wind structure at the phase you're looking at the planet. Additionally, this lets us look a little bit deeper into the atmosphere than the transmission spectroscopy method earlier. So these two methods are complementary to each other, and you can combine them to get information about a larger swath of the atmosphere. And so what this GIF is showing is, again, we've got one of the planets that I've modeled. This is an ultra hot Jupiter, I believe. And as the planet rotates, the corresponding emission spectra is highlighted on the left. So when the day side is in view, the total flux or the brightness is going to be the greatest because that's hotter things will be brighter. And then as the night side comes into view, then the spectra gets lower in flux and the features change from emission to absorption. And this is sort of a big part of my work is trying to tell people how important 3D models are, because even though these models take a week or two to run, they do a better job of capturing the physics, and these planets are very much 3D. So, in summary, hopefully I've taught you that, or convinced you that hot and ultra-hot Jupiters are a really interesting class of exoplanets because there's nothing like them in the solar system. And they're also really observationally nice to detect and study because of how bright and big they are. The most important features of these planets are they've got this permanent day side and a permanent night side, which causes all sorts of crazy winds to go around the planet. And also, we've got various different methods that we can use to observe these planets that we can then compare to our 3D models, or 1D if you're not as fancy. But yeah, hopefully I've taught you a thing or two and I can answer any questions that you have.
So do most of these hot Jupiters have tails? Are their atmospheres being blown off of them by the star?
Yeah, so there's definitely some level of escaping atmosphere for a lot of these planets. Definitely maybe more for the younger planets, for the planets that are closer to the host star. And we can detect some of that escaping atmosphere usually through helium. It has a really nice line that is associated with escaping atmospheres.
How close are some of these? How close can some of these planets be?
Yeah, so the I've seen ones that orbit in less than a day. So they are definitely really zooming around their host star. Less than a tenth of an astronomical unit.
Wow.
Very, very close.
Yeah. Thank you.
When you look at the wobble of the star and the planet as you're measuring them, there's of course a change in the spectrum. How much variation do you get in terms of wavelength? Is it in the tens of nanometers, a fraction of a nanometer? What's the difference in variation?
Yeah, so that'll be a function of how massive the planet is. But as far as the magnitude and wavelength, it can be so okay, hold on, let me convert to nanometers. Order of a couple nanometers, depending also on how far away the star is. But usually the sort of sinusoidal pattern that we see is very indicative, and that can help backtrack and to figure out how massive the planet is. And so it depends on a lot of things, but not a huge amount. You have to have a pretty sensitive instrument to measure that wobble.
Oh, very good. Thank you.
All right, any other questions? Well, thank you very much for joining us. Hope to see you again around here.
Yeah, thank you for having me.
It's time, I think, to take a little 15-minute break.
Yeah, do that, and we'll come back and do our panel discussion.
Do a panel discussion at 8:30. And
Great.
Haley, please stick around for that if you'd like to see our panel discussion.
Sure, thank you.
So I have posted a couple links in chat, NASA's exoplanet archive, where you can go and see all the exoplanets in table form and all that stuff. And also Eyes on Exoplanets, which is allows you to explore everything that NASA's discovered up to yesterday in a graphical format. So those links are in chat.
So how fast are we discovering exoplanets these days? I mean, like a couple a day almost? I mean, it seems like a lot.
couple. I report on it every week, and it's about a couple every week now.
Couple a week?
It's
Okay.
yeah. I'm seeing it go up by a couple, and let's see. The next exoplanet archive today says 5845. No, that's test 5084 confirmed, with a whole ton, about an equivalent number of candidates that have yet to be confirmed.
Thank you.
Well, that's just crazy. I've commented that on the graph of asteroid discovery, right? It's going up on an exponential curve right now, but eventually it's going to start curving over, and we're going to be finding everything. Exoplanets ain't going to do that. That curve is never going to go down.
I've been at lunch watching my meeting. I've been doing it on my iPad because I can take it with me. It's much better, and it connects better with WebEx and Zoom all the time. So what I'm able to do is I'm able to take it with me. I can put myself on mute like I am now. You turn off the stuff on mute.
Tripping stuff, Kenny.
Coming up on, well, it's 8:30. All right, I'll give everyone a few seconds to get back to your seats and all.
Mosey on back.
So I have a question about astronomy at the beach tomorrow.
I have an answer.
Yes.
Let's see if they match.
So it's Friday and Saturday, and
Mm-hmm.
the weather doesn't look perfect either day. So is it going to be clouds? Is it going to be dust? Is smoke? Whatever. All things considered, if I only had to choose one day, you think Saturday is going to be more people because it's a weekend?
Probably. I think Saturday has historically been more people than Friday.
Saturday is historically far more people, sometimes by multiples of 2 or 3.
Okay.
Saturday also has the worst weather forecast.
Yeah.
But Fridays definitely, because we have very good survey data from the last few years, thanks to Brian Autumn, and
Okay.
Fridays are definitely more lightly attended.
Are you guys meeting at a particular spot?
Yeah, there's a map on the Astronomy of the Beach website. There is a map that you can download to it, but it's inside the park, and there will be astronomy event signs.
Well,
all the
I
way.
meant the Warren Group at a spot within the spot.
Yes, there's going to be a tent, and all the astronomy clubs are going to be set up there. So if you want to sit and represent the club, you are more than welcome to do that.
Yeah, I thought I might bring something.
That'd be cool. We could use somebody behind the table.
So.
All right, it's 8:32. We want to get the show on the road?
Yep, let's get on the road, Bob.
Alrighty, all right. Welcome to our main presentation tonight. Tonight we are doing a panel discussion. What fascinates you about astronomy? And so I am your first vice president and a volunteer NASA JPL Solar System ambassador. And format tonight is being modeled after science fiction convention panels I've been at, where my wife and I have been part of. So I also do that. And speaking of my wife, there's my wife at a science fiction panel. So I'm going to start off, and I mentioned in our other panel discussion about what got me into astronomy in July was the Apollo program, but that's not what I find most fascinating about astronomy. There's a lot of things that fascinate me about astronomy, but I think the chemistry of space is pretty much the most amazing thing ever. I mean, there has been dozens of chemical compounds discovered in the interstellar medium from 2 to 10 atoms, and a lot of them are organic, which is really, really cool. Glycine, an amino acid, has been found. I can't even pronounce that or those last two. A phospholipid, which is what in cell walls. This has been found.
Glycolaldehyde, ethanoalamine.
Those have been found in the interstellar medium, and glycine, and some of those other things have been found in meteorites that have been falling from the sky, has been reported like this. So when our solar system formed, all that stuff was already there, and when those meteors are falling to the planet, all that stuff was already there, just like it's still there. So as a movie once said, life finds a way, and boy, did it ever on this planet. You know, the chemistry of the interstellar medium gives infant star systems a ready-made precursor to life kit. And I'm thinking that the likelihood of life on exoplanets in our galaxy might be a few percentage points higher than what the Drake equation predicted. So that's my what I find fascinating about astronomy. And I wish I knew more about chemistry because I just find this fascinating. So unfortunately, David Levy is not here. I was going to have him talk. So is Jim here? Jim is not here either. Wow, my speakers are not here. Well, Adrian is not here. Well, okay. How about, even though you're not there, how about you, Diane? Because I know you have something to contribute.
All right. I figured something like this would happen when I was looking at the roster. All right. So, what's your first question then, Bob?
Well, it's just it says you got what got you into astronomy is not what you find most fascinating about astronomy. There's got to be one thing above all else is just tweaks you when you see it and you just, gosh, that's cool.
So I've always been very into the fact that we are looking at the same stars as our ancestors, the ancestors of every human on Earth, and then the precursors to humans, and then going all the way back. So one of the things that first got me fascinated about astronomy was when I was very young, and I taught myself to read when I was 2 years old. So I could read by the time I was 3. By the time I was 4, I was reading the big National Geographic Our Universe book and scaring myself, reading about the death of the sun. But within a few years, I was reading works like Chet Ramos' 365 Starry Nights, which is a very 1970s humanist sort of Carl Sagan fan intro to stargazing, basically. Lots of little flights of fancy with line art of aliens and stuff like that. So Ramos' poetics and his flights of fancy really grabbed me. And one thing that caught my eye as a, literally 7 or 8-year-old was the idea that Betelgeuse, big red star in the shoulder of Orion, one of my favorite constellations, that Betelgeuse had been a white, or that had been a dimmer star at different times in its life, because it's the rare case now where it's the beta star and the alpha star in Orion have a swap magnitude. And also Sirius, which is frequently described by the ancients as red or ruddy. Well, of course, Sirius is a white, bluish white, very bright star, but it has a companion, Sirius B, which was not known but to the ancients. So the idea that Ptolemy would have been looking up at Betelgeuse and Rigel with strikingly different variance in magnitude than we see today, or looking up at Sirius and seeing it as a red giant, more like Antares, than the white star that we see, just really set my brain on fire. Unfortunately, that did involve a little detour through some astrological stuff. But thanks to the way that science in many fields is increasingly taking heed to the oral histories of indigenous peoples and able to model things that computers of the 1980s could not begin to model, we're finding out things that are actually science that have that same sort of wow factor. And one of those was a report that I shared on Facebook just a week ago, which was Betelgeuse, which of course is red now, may have only attained that ruddy hue fairly recently, and earlier generations of humans might have seen it as a yellow star. And that's got some backing to it. So that sort of thing really really grabbed me. And some of the things, as I said, were pseudoscience. Like, I remember reading a book when I was a teenager that talked about there had been a period where the Earth's axis went straight up and down, and the Little Dipper would have gone around the North Pole perfectly. Yeah, okay, that never happened. We know that the Earth's axis may have wobbled a little bit off 23 degrees, but we were never oriented straight up and down. We never got knocked off balance by anything. So yeah, some of those books were bad, but that's the nexus of poetry and astronomy. Sometimes those poetic flights of fancy go some really weird places.
Awesome. Thank you. So, Ken, I know that
Yeah.
you've got something to contribute, and I'm going to guess it's size and distance, so the vast size of the universe.
That's what got me first, was
That's what
size
got
and
you
distance.
first.
When I found out about Betelgeuse or Betelgeuse and Antares and their massive size as comparison to what we are, the Earth, it just blew me away. And then I constantly tried to find bigger stars that were there, and there are a whole bunch of them that are even larger than that. That blew me away first. But what got me more often now than anything else is trying to figure out dark matter and dark energy. When they were talking about the fact that the universe expands faster than the speed of light, I went, huh? That was pretty much my first thing. And now it just completely involved my interest. And they're not learning anything, I guess, about dark matter and dark energy. And the fact that dark energy and dark matter make up 95% of the universe, apparently. That's what they're looking at, right? I guess that's the newest thing. It just boggles your mind. The fact that you could get on a spaceship and travel to a distant a galaxy at the speed of light and it's moving away from you just blew me away. Just blew me away. And those are the things now that really that impact me. Size and distance is still very interesting, but wow.
You mentioned dark matter. One of the Vatican Observatory scholars works. She's from Rome, I believe, from Italy, has been working on dark matter research, and they're using the most sensitive instrument ever made, and it's just ridiculous how this thing was built, and they ran it and they didn't find anything. So, but they ran it for like 60 days. They're going to run it for like 1,000 days, but they didn't find anything. So that's not a horrible result, because now that gives them an idea where else to look. But still, I mean, there's been like a dozen of these ridiculously huge experiments. They're not finding anything.
And the other three objects that kind of blew my mind were Enceladus and Europa and Titan. Titan kind of got my attention because of the atmosphere that it's got, and the fact that that's a landable place and could be, terrific for us for fuel things and things like that. That also kind of got me as well. So every day
process is like ours.
Right, the weather is like ours. That's astounding to me. So anyway, astronomy for most of us, I guess, just fascinates us each day with something new that comes up. Even the stuff today about the planets that were close to the stars and the big super Jupiters, it's spectacular stuff. What doesn't fascinate me about astronomy?
That's the problem. That is the problem right there. Is this? I could go on, picking one thing is tough, because I'm looking at my wall of pictures behind me, and I'm like, well, that's cool. So, so Doug Bach, I know you've got something to contribute. No?
Yeah. Excuse me. Yeah, I do. Can you hear me okay?
Yep. Sound good.
Yes.
So I'm going to start with a little bit of what got me started, and then what really fascinates me. There's several things, but since I missed the discussion about what got you started in the first place, 1965 was my first view through a telescope at Saturn and M13. And I think my fascination at that point was there's a lot of cool stuff out there. I need to go find out. And so over the years, I started getting interested in the physics involved in the universe, celestial mechanics, stellar evolution, planetary composition. But celestial mechanics is a course that I took in college, which also taught me how to take observations of comets and asteroids and actually compute their orbits based on multiple observations over a period of time.
I want to talk to you about how to do that. I want to know how to do that.
And so what you do is you compute the orbital elements that you discover, and then you can compute the actual orbit itself that those elements get you. You can determine the inclination, the eccentricity, several other parameters, and then you can calculate an entire orbit. And you want to refine that as you get more observation. So the physics is what really has interested me all along. Not just the observational, it's kind of cool to look at all this stuff, or the astrophotography to be able to do some of that. But if some of you kind of know that I go after asteroids and comets as well, probably a little more than anybody else in the club. And one of the cool things about that is I can take those measurements and determine an orbit from them, which one day I'll give a talk on, but not yet.
You don't submit those to anyone, do you?
No.
Like the IA? Why not? You can submit that stuff to the IAU.
It's a mental exercise that I just like doing. Besides, if I join something like the AAVSO or send stuff to the Minor Planet Center, they'll expect stuff from me, and that puts me on the hook. But maybe someday I'll start doing that. We'll see. But the physics has always intrigued me, especially the celestial mechanics and stellar evolution, the formation of stars, the formation of galaxies, and some of the cosmology that those guys have been working on interests me as well. Yeah, I like the pretty pictures. Yeah, I like just going out and. Oh, well, the other part is what can I see with my naked eye over the last 50 years? What is the dimmest thing I can see with any given telescope that I have at any given sky? That interests me too. And people have found me to go look at the most obtuse things that you could just get with a little bit of averted vision with your 14 or 16-inch Dob, whatever, or my 18-inch Dob. What's the deepest I can get? This is a really good night, right? So testing my observational skills is kind of part of what I like to do as well. Is how good is the night with this given scope, with these given failing eyes that I've got, right? And they are failing, by the way. They are getting worse.
Yeah, so are mine. I mean, I used to be able to make out Mizar and Alcor, not anymore.
But for example, this next week I'll be up at the Great Lakes Stargaze. I'm probably going to take my 14-inch Dob and do some observational stuff, which I haven't done for a while because I've been burying myself in astrophotography for the last 5 years. So I may go up there, and one of the tests whenever I go up to my place with the 18 is, okay, the sky looks like it's it's really dark. Maybe it's a 21.6 SQM reading, right? Okay, well, how's the steadiness, the seeing? Well, in the fall, I use Stephan's quintet to see what that looks like in my 14-inch. If I can easily see all 5 of them, then I know it's a good night with the 14. If I can see just the blue one and the 4 that are in the yellow band, or maybe not quite there, but the blue is there, then I know it's not such a good night with the 14-inch, even though it's a dark sky. That means that there's either some upper atmospheric turbulence and a little bit of haze, so the transparency is not all that good. In other words, when the conditions get good, you can kind of mentally record that year over year at a same location, and kind of determine the quality of the sky independent of your instrument, like an SQM meter. Those kinds of things, collecting data and doing the physics, mentally at least doing some of the physics in your mind about what's going on. And sometimes it's just great to sit in a chair and watch meteors.
Well, there's always that. Lay out on the beach and watch the aurora.
Yeah.
That was awesome.
But in general, I've kind of taken the technical track on the hobby over the last 50 years. I mean, look at the astrophotography I do. I put together a system in about 2 months and been using that fully automated. I go to bed when it's running, so they use the whole night while it's taking data. And the reason I did that was we only get so many clear nights here in Michigan. And while I was working, if you had a clear night on a Wednesday, I might in the late fall, I might get about 4 or 5 hours and then have to go to bed before I go to work. Well, now I start up at dark and it runs all night, parks itself, and I just pull data down in the morning, so that I don't have to worry about staying up late to get information. Yeah, it's not observing, but it is a way of collecting data. So the technical aspect was always intrigued me. I've always been kind of a technical guy. My whole career was as a technical specialist, and so that was part of it. I mean, I helped automate the observatory at MSU back in 1976. So that was when I started doing software development for the astrophysics department. So it's something I've always enjoyed doing, and it just so happens that astronomy is always looking for something new to do.
Constant change.
So if there's any questions about any of that, I'd be happy to talk about it.
I'd be interested in hearing what Riyadh has on that.
Not a whole lot. Actually, I'm kind of like more interested, 60%, I would say, maybe 70% in the actual equipment of observing, and the rest of it in actual observing itself. So that's kind of my interest. And in terms of observations, it's nice to look at deep sky objects, and I've seen a lot of them, and go back to some of them to view from time to time. It's they're basically, you can't see much of a change in them, but I find that as kind of comforting. It's sort of like seeing an old friend. Every time you see during nebula, the first time in the summer, or the Orion Nebula the first time in the fall, it's always good to kind of look at that. But more interesting to me in terms of observing is looking at double stars, simply because I've looked at them before, and back in the 80s, we used to use bifilar micrometer. One of the guys that I used to observe with, Doug, I think you remember Steve Franks.
Oh yeah,
he had a Darwinian measure the separation and position angle of a lot of double stars. So that kind of got me pretty interested in doing that, and I'm still interested in that. Unfortunately, the equipment is not that much available anymore, but in terms of being able to do that kind of work, you can
Are there specific stars that you measure that? Because I know some double stars can take like 100,000 years to orbit each other, and you're not going to be able to see much of a change in that in your lifespan.
Correct, but you could still measure them and take the position angle. That's correct. Now, some of them are much closer than that, the tighter doubles, and some of those, like Sirius, for example, I think it's 26 years or something like that. So yeah, within your observing career, you could see something like that, maybe even orbit twice, or something within that range. There are double stars that I used to look at, like Zeta Bootes, in the 80s, and it was just a little bit below 1 arc second, maybe 0.9 or something like that. Eventually, a few years ago, it closed so much that you can no longer separate it. So now I can look at the same star, and it no longer looks like a double star. At one point, you could just barely see elongation on that star when it was about 0.6 arc second. Now it's going to start opening up again. So that's a lot of fun for me, to be able to see some of these stars that you could actually see them orbiting each other, and be able to measure them. Now, also the equipment, like I said, is of a lot of interest for me. So unless you have something that has good high resolution good optics, well, you're not going to be able to do that. And nowadays, what I was saying also is maybe the ability to use CCD cameras or the new cameras that are available now. You could also actually measure double stars and their position angle just by using cameras. So there are lots of techniques for doing that as well.
I just looked up Zeta Bootes on Wikipedia, and they've got a 45,000 day orbital period.
Yeah. So, but yeah, in terms of equipment, absolutely. Looking at things like the spectrometer that I'm looking at trying to get for us. These are things that are, to me, that are actually amazing. That you'll be able to, even with something that's not very expensive and can be purchased by any of us with our equipment and our budgets, you can actually, at least on some of the brighter stars, you can actually tell what their kind of composition is like. And if you look at, one of the brightest quasars, I think it's 3C273, you could actually see not just the composition, but also the redshift. And this is with just amateur equipment. So to me, that's kind of mind-boggling, actually, that you can do that kind of work with something that we can afford.
I have to admit, spectroscopy as a whole is just mind-boggling. The whole concept of how it works, everything is just like, wow. All right.
Yeah, so these are my interests.
Thank Riyadh.
I also am, as you know, very, very interested in the history of astronomy with all my presentations and such, and how the science itself has evolved really within, since the 1500s, and all the things that have gone on between some of the great astronomers like Galileo and Kepler and even Barnard and all these other people, that they constantly find new things, and how the universe has literally expanded in what we know. It wasn't that long ago where the universe was just the Milky Way, pretty much, and then all these things that happened since then, and these contributions by these incredible individuals is also fascinating, and their lives and such, and that really hooked me a little bit, in the 80s and 90s, really, to start. And it's just been a transition period for me, as my interest in astronomy has just like you said, Bob, it just evolved, and it just changes all the time.
Well,
And
the other thing,
I watched some of these photos, like from Doug and Bill and some of the others who are really, really talented in what they do with that, and just am blown away. I always told people that I didn't get into the photography because I know all these people like Espinac and other people that I'm never going to touch that type of, uh, of expertise in that area. So if I need a picture, I go to them, and show it to somebody else, and that's the other thing too. So we got so many resources.
one of the things I'm glad everybody's brought up different things that they found interesting and stuff, is the fact that, when you talk about astronomy, and it frustrates me when it comes to teaching astronomy in the school, because you know, teaching basic astronomy is fine, but in order to go to advanced level, you've got to know a little bit of chemistry, or to go further, you've got to know a little bit of physics and that kind of stuff. And, it just encompasses history, observation techniques, technical aspects, art. All, astronomy is huge. And, I'm really glad that everybody here is bringing up things that, different aspects of it. So, Dave Hollenbaugh, how about you? I know you've got some interests. Calling Dave. Anybody else want to chime in?
Dale Hollenby, actually.
Dale.
Caught me. I was actually working on a solar image. So
Tell us about that.
where do I start at? So, you know, you guys were talking about a little bit about your history, and I gave a presentation last year about, you know, how I got into astrophotography. But, you know, for astronomy, I've been interested in astronomy probably all my life to a certain extent. I'm going to come at it from an interesting side angle. Is, you know, watching science fiction, and you see these fantastical things, and it's entertainment, and you start thinking like, well, can that kind of stuff really work? And then you sort of trying to go backwards and learn about certain things in reality, science fact, and try to sort of meet somewhere in the middle. And it really helps with understanding, I think, of astronomy, and sort of foster an appreciation and uh, an interest, for me especially, um, you know, to get someone excited about the hobby. I don't have the observing experience that most of you do. I didn't do it for years. I didn't really have a telescope and so forth. One thing that Riyadh mentioned, and I really get into the equipment. I'm a mechanical engineer by trade, and I love delving into the minutia of optics and how things are constructed, and how the telescopes, the different types of telescopes, how they work, what are their nuances, and, you know, what makes a refractor better than a Newtonian, better than, you know, Dobsonian versus a SCT and so forth. You know, hey, Hubble, what type of telescope is that? Why did they choose that optical formula? Why is plane wave? Why are they different? Why did they choose that? You know, actually, at Astronomy of the Beach, I was there. I was very young in my astronomy journey, and I spent a lot of time with, like, the director of engineering for Planewave. He was there showing off some of his stuff. He's a astronomy geek like the rest of us, and he was telling us about some of the differences and why he chose some of the things. And I was really fascinated about what he was talking about. And I was a, you know, 6 months into the hobby. But really, I would say the thing that sort of brings it back to me is my love of photography, and um, delving into astrophotography and really accepting the challenge. I think it's probably the most difficult form of photography, and that really drew me in the last 4 years, I would say. So that would be the number one reason, you know, recently why I'm interested. But you know, historically, all of these things combined, you know, it's a recipe. Well, how does anybody get into it and stay in it? And those were some of the factors for me. So here, let me share my screen. I don't know if we talked about any solar stuff. I was at work.
Yeah, the sun was fairly exciting yesterday.
So I took this. It's actually on September 22nd. So when I took, yeah, I've had a lot of data that I've recorded, but I haven't had a chance to look at it.
Boy, that filament prominence over on the right's pretty cool.
Well, hold on a second. My wife just said August. Look at this data.
Yeah, it's only September.
September 1st, not
Yeah.
22. It's not August 22. It's not September 2.
Yeah,
It's
that's next
September
Thursday.
1st, 2022 is when that data was taken. Okay. Yeah. So I went through and processed it. So it's pretty active there, and I'm trying to get some reasonable colors, just as we were having the meeting here in the background. So I thought I'd share that for a semi up to date. I guess it's really 2 weeks old now, but just with a backlog of data. Yeah, that's my
Nice. Well, thank you.
my contribution.
Anybody else want to chime in? What fascinates you most about astronomy? Well, since everybody is going off on tangents, I mean, and being hard to pick. I mean, y'all, if you've known me for more than 5 minutes, you know I can't shut up about asteroids, and it just blows me away the discovery curve just on near Earth asteroids, and and again, the fact that we're finding amino acids and organic molecules and stuff in them, and meteorites, that's kind of cool. But I mean, when I met my wife up at Michigan Tech, one of the things we did was, set the towel out on Lake Superior Beach and watch the aurora for hours and hours, and that was just amazing. The sun. I've got a presentation on the sun. I find the sun amazing. I always wanted to get the reaction of the scientist who figured out that fusion was going on, because he must have gone, "Oh my God," when he figured it out. That just blows me away. So again, there's a lot of things that blow me away when it comes to astronomy, and it's really hard to pick.
Well, one thing I haven't seen anybody mention really in depth yet, Bob, is funnily enough, human space flight.
Well, that's what got me into astronomy, was the Apollo program,
Yeah,
and I've been following that my entire life. And the one thing I remember about the shuttle was that I was at Michigan Tech in a dorm TV room, and the first shuttle went up, and that you could standing room only. Second shuttle went up, there was a few seats. Third shuttle empty. I was like, wow. And I'm really glad to see that NASA has been putting a lot of money into media and promotions and getting the public enthused about the program. But Artemis better go up, or otherwise they're going to be suffering some real negative press. I don't know. I don't know what's going on with it. Oh, speaking of well, not human space flight, but just space flight. The DART mission impacts the asteroid on Monday, and Solar System Ambassador team has sent out their NASA wants to have people do watch parties. Now I'm thinking to myself, okay, it's going to impact. Okay, that's over. What now? I mean, it's not going to be much of a watch party much as I can figure out. But I did find out that it's going to change the orbit of the impact by a a few kilometers per second. So and it will be able to, but they'll be able to tell that from Earth telescopes, which would be cool. So that happens on Monday. First planetary defense test.
I
So,
think that's what they should be looking at. I'm, again, you've heard me pontificate about I don't like human space travel particularly, and I think we waste money doing it because there's so much we can learn with robotics. If we put that stuff to use, I mean, the old thing is, let's say you decide to go to Mars, where are you going next? So the point is that
Jupiter.
yeah, it's fun, and it's fun to go to the moon, and it's fun to have the space station and all that other stuff. And the space station is okay because they learn a lot of things from that. I just have a problem with deep space travel. I don't think it makes sense with the life expectancy of human beings unless we can break the laws of physics or something.
Shield.
So,
If we had better shielding, that would be awesome. But I
yeah,
don't.
I agree.
It's like you're flying around in a microwave oven, kind of
Yeah,
like, and it's like
I get that.
Hey, this is supposed to be a panel talking about the stuff that inspires us, not the
But
stuff that
anyway,
I
kills
get
okay,
it.
us.
No,
so
I'm agreeing with that. I'm saying, yeah, I'm trying to stay off of that subject, but I'm saying we've got a lot of capability here, and every time you're like the Webb telescope, fabulous stuff. Even the Hubble going up, all that stuff is grasping you, you know. And the only reason I don't say anything about human space travel because I think that yeah, it's got some fun to it and everything like that, and it's interesting. I'm not taking anything away from that either. Going to the moon was cool. It really was cool. Um, but I think we could do better. That's all.
So one of the things that Diane brought up was, things that interest me. Okay, one of the things that I use this app called SpaceEngine that lets you explore the entire universe and anything within about 6,000 light years is accurately modeled, and they've added all the exoplanets in as of like May. So those are all accurately modeled. But one of the things I love about it is like we mentioned Sirius. You can go to that and see all the stars of Sirius and do time acceleration and see how they orbit each other and see the play of gravity. And that is just amazing when you see stars orbiting around each other that are doing that. That is
Spectacular.
that is just cool
That's
when you see
spectacular.
when you
It's
see
so
that.
cool.
And the fact that there's so many double stars and quad stars
Oh
out there,
God, yes.
that's crazy.
Yeah. Don't get me wrong, Diane. I love every aspect of astronomy without question, and every day something else fascinates me in particular. And I just think we are going to be. It's going to continue. It's going to be just terrific stuff all along, and we're very lucky. And the other stunning thing that I've discovered about astronomy is how little people know about it.
Oh, I've
You know,
known that for a long time.
and how little they are interested in it, and you can only look at your feet so much. You know what I mean? Look up a little bit.
Well,
So,
that's all of our jobs is
and
to get
that's
the
what
rest
we
of the
do. Get them
planet
interested, right?
getting interested.
That's the key. You're right. That's the thing. We got to get it excited. Get people, push the button on them, and see to make them understand how great it is.
I mean, I think that asking, a panel of people who are hyper involved enough in astronomy club that they meet 2 to 4 times a month to do astronomy stuff is like, well, every single one of us who spoke tonight has a different entry point. There's
Sure.
not a universal way or even a generational way. Obviously, as per the previous panel, a lot of people were galvanized by Sputnik and then Project Mercury, Gemini, Apollo. Okay, well, that's a very long time ago.
Sure.
And some of us got into it through reading, some of us got into it through television, some of us got into it through
Chelsea Bonestell.
Yeah, exactly. And with skies in suburban areas being exponentially worse than they were even 20 years ago, the whole, well, look up, like I did stargazing with my grandfather on our driveway in a town just north of San Jose. Now, thanks to California's stringent rules and the proximity to Mount Hamilton, that suburb of San Jose is markedly better in terms of dark skies than, say, Sterling Heights. But leaving there when I was about 8 years old and not returning until I went to college, tracked with a trough in my interest in astronomy, because from my new home in Tennessee, where it is a pretty sprawling city and there were no sorts of any light pollution safeguards, the sky was orange a lot of the time. I joked that we lived on Mars. I couldn't see anything.
Isn't that something? Wow.
And I went back to college, aged 18, and I was walking across the campus that first winter, and I looked up and I saw Betelgeuse and Rigel and Sirius the way I had when I was a kid, with the colors hitting my eyes.
How cool.
And most people aren't going to be able to turn back time like that.
Well, like in Ann Arbor is a good example. That what her name is, Sally Oe, is that her name? What's her name? Yeah.
Sally,
Anyway,
yeah.
and she's now pushing that for for a lot of cities around the country. She's wonderful, and that may make it better for everybody. Tucson has a rule in there too. You go on a mountain that's 10 miles away from Tucson, and Phoenix, 120 miles away, is brighter than Tucson. I mean, it's
Right.
just that and we can do. There's things we can do to take care of that, and that would be great because then you get the public gets to see it. This thing with the Starlink and all that other stuff, you'll still get to see the sky. But a point is light pollution. There's cities that are actually making efforts to get their skies clear enough so you can look up and see something nice, and that's great. That's super. Yeah.
In a lot of instances, people just don't even know to do that.
Well, that's what I'm
I,
saying.
I
That's
and
what we do. We get them excited about that sort of. Our type of attitude gets them excited about that, and some people start to do it.
Well, that's
I
why
just
I think it's, one reason that we hype Astronomy at the Beach is it is an event geared at the general public.
Exactly.
And that is why we do it even when the moon phase isn't advantageous for astronomers, because it's not for astronomers. We have fun.
Mhm.
I won't be able to bring a scope tomorrow because I work in Grand Rapids tomorrow and I'll be
Oh.
literally coming back after a 9-hour day, but I at least want to look through somebody else's scope, preferably
Sure.
the big Dob. But we're there for people who otherwise are not going out to Island Lake State Recreational Area and its decently dark skies to look up.
We are. I've watched you and Bob and myself and Riyadh take these kids that come out and start talking to them about astronomy with it, and these kids are wide-eyed and just in interest about it. And our one of the fine things about astronomy is we can teach that, and we continue to push the thing. The thing that always got me, which was actually was astronomy at the beach, when the guy came up and he says, "I believe there's USOs and we've been visited." You remember my remark? I said to the guy, "Well, do you believe that the laws of physics can be broken?" And he said, "Yes." I said, "Then our discussion is over." I got nothing to tell you. What am I going to say? So, yeah, that was and there are people that are rock hard in that area, and then you have people that say, "Really?" I like the person that says, "Really?" That's cool, and that's what you got in society today. But I think the Warren Astronomical Society has done wonderful things with people. No question about it. We are very good at what we do, apparently. Uh, and the photography and the work with the telescopes and the deciding to do an 8-inch refractor, I thought that was a fabulous decision. Fabulous decision. And we're getting people interested. And that's if you want to talk about what excites me about astronomy, right now that's it.
Oh, I love the oh wows in my telescope.
Oh yeah.
I was at a science fiction convention years ago, and a young lady saw Saturn for the first time through my big Dob, my 8-inch, and she freaked out, ran back into the hotel, and was screaming down the entire lobby of the hotel. You gotta go out and see Saturn in this guy's telescope. I'm like, cool, but
Heck, I didn't know while looking at Saturn through our 8-inch last week. It was pretty good.
When you can pick up the moons and things like that, which are pretty good with Saturn and such. And I was blown away, Riyadh, with the look at Neptune the other night. I mean, it wasn't spectacular, but it was pretty damn cool.
Yeah, it was a little bit dim because we were using that 6-inch mask, but it made everything we were looking at much sharper, including
Sure.
Saturn, Jupiter, and later on Mars.
Just so cool. It's great.
Yeah, it was.
What's aside from Saturn, which everybody got blown away about? What's the first object you looked at aside from Saturn that really got you?
The trapezium,
Cool.
the
How
four
about you?
little stars inside the Great Nebula of Orion.
How cool. How about you, Riyadh? What was the one thing got you?
Besides Saturn,
Well, I mean, aside from Saturn. Saturn's the hook.
Yeah.
Mine is
Well, the first
M13.
time
it?
I saw M31, I was sitting behind my parents' house in the backyard in Madison Heights. And with a pair of binoculars, I was determined that night I was going to see M31. I had maps, I had everything with me. There's no way I'm not going to see it. And I looked and looked and looked, and finally I got it. And I nearly jumped out of my seat. I got it.
For me, it was Jupiter and seeing the moons of Jupiter with an old Sears refractor when I was like 10, 12 years old.
Very cool.
And then
That was
later
me.
Saturn.
Did your Sears refractor have foam rubber focusers that dry rotted like mine did?
It was my older brother's.
Ugh.
I don't know what it had.
Yeah, but I remember I had a Sears Roebuck refractor when I was 8 years old. That's exactly what I had.
I had a little Tasco, and I saw Mizar and Alcor for the first time. That was the first double that I ever looked at. And I just said, whoa, wow. And you see Mizar with that little double right there. Wow, it was so cool.
So mine would have been M13. I think that would have been like the first or second thing I looked at through my Dob. And I took it up to the Upper Peninsula, and we were at McLean State Park. We're right in Lake Superior. I set it up, and oh my God, the skies are dark there. And I I remember I set up my Dob, right. It was so dark. I'm looking at the sky, going, "There's too many stars. Where are my guide stars? I don't know where I am." And it took me a while to find it, but so finally found it. And my buddy from England looked at it, and his head just jerked away from my Dob, going, "Oh my God, is that beautiful?" And it was so clear, it just looked like diamonds. And I think I've only seen it look like that once.
Well, when I was in South Africa, I looked at Omega Centauri for the first time.
I have not seen that yet.
Oh my goodness gracious! And it was with a little 6-inch reflector, a little one of those ones that sit on a table and things like that. And I looked through that thing, and I just said, "This can't be."
You've got to try the Point Pelee
Really?
challenge, Bob. See an sent from Canadian soil.
Oh, really?
Yeah.
Really? Wow.
When are we doing that?
It's possible like 2 or 3 nights out of the year in winter.
Oh, really?
I was just gonna say, how far south do you have to go to see it? Is like
Point Pelee is located at 42 degrees north latitude, so it's south of Detroit. It's the southernmost part of Canada.
Wow.
And that's the kind of stuff that fires my imagination.
Exactly. Me too. I love that. Absolutely.
You're looking over a lake, so there's nothing, on the horizon. That's why it's interesting, and that's why it works over there. Yeah. I tell you what, the out of all the images that I've seen, the one that I remember the most and vividly is looking at the Orion Nebula M42 through the Detroit Observatory refractor, the 12-inch refractor, back in the 80s when they used to let us do that. Absolutely amazing image. Still just kind of stuck in my mind. Yeah.
Burned a hole in your imagination.
Yes, it did. It's not going anywhere.
It's not going anywhere.
I forget what I had for dinner tonight, but that I do remember.
Right.
Well, we're almost to 9:30, gang. Anybody got a few parting thoughts? Bob, as our moderator, do you have any closing thoughts?
Not really. I'm this as happens at science fiction conventions. Tangents were gone off on, but that's just fine. We all shared what we found interesting in astronomy, and as with me, everybody has a lot of things, or more, sometimes more than one. I've got 1,000. There's very little in astronomy I don't find interesting, which is a problem.
I think if one had a mono-dimensional interest in astronomy, one would not be committing to multiple years of being in this club. you'd take up like parachuting or something.
Hey, there's still a chance. But anyway, astronomy at the beaches tomorrow. Says I unfortunately will not be there, but I will be giving presentations on via Zoom. If you'd like to come and join and heckle. I've already invited my friends from General Technics, my science fiction and science fiction convention buddies, to heckle, and somebody said, "Oh, I'll be there," and I'm like, "Oh, great!" So come and meet some of my friends. They'll tell you stories about me I don't want you to hear.
I have scouts tomorrow at the observatory, so I won't be there, but I'll
Awesome.
be there Saturday.
Excellent. Yeah, I intend to pass through if I'm still on my feet after 9 hours in Grand Rapids.
I'm going to be there both days. So,
What days?
oh, by the way, I'll do a little table stuff for you, Bob. Okay.
Nice.
Okay. It was great. Great discussion tonight. Loved it. Super. These
All right,
panel discussions
everybody.
are fun.
Thank you all.
That concludes the talkie portion of the meeting. Sorry there's no Coney Island, but
Well,
maybe someday.
go get yourself a Coney right now.
We don't have any 24-hour Conies on my side of town.
That's sad.
It's very sad. Jonathan and I are very unhappy about it.
Anybody who missed Jim
either.
Soblowski's talk the other day really missed something great. Good job, Jim.
All right. Good night, all. Doink, 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 leaving.